What is a symmetry in mathematics? Actually, it's a transformation that leaves a mathematical object unchanged. For example, what are the possible symmetries of this equilateral triangle? Dr. Athar, would you like to guess how many symmetries we can have?
People are saying three.
Three. Okay.
In the audience, people are saying three.
Okay, three. So actually, there are three lines of symmetries in the case of reflections. So there are three symmetries in this case, and then you have three symmetries of rotations. The angle of rotation in this case is 120. So if you rotate it like 120, this will be one symmetry, and then if you rotate it like 120 plus 120, 240, this will be another symmetry, and then the last symmetry is the rotation by 360 degree, which will take it back to its original form, and that symmetry is known as the identity symmetry. So this is how we mathematicians define or look at the symmetry. In this way, they actually quantify all the possible symmetries of an object. Okay. So for example, and how many ways you can translate this, the lower hand. So in this case, this object, if it is going like up to infinity in the both directions, in this case, the number of symmetries will be infinite. So the group of symmetries in this case will be infinite. But in the first case of triangle, we have a finite group with 6 symmetries. So here you can see two different groups. One is the finite group and the other is the infinite group. And the infinite group, the lower infinite group is somehow still discrete. What about circle? If you take a circle, let's suppose if you take a circle, and how many symmetries you can have?
Infinite.
Infinite, very good. Yes. So circle will have infinite symmetries. And similarly, a sphere will have infinite symmetries. And those infinities are sometimes not countable actually. These groups, infinite groups, are important for physicists and also for mathematicians. So when we look at two objects, let's say a triangle and a circle, we say that circle is more symmetric than the triangle because they have more symmetries, because there are more ways in which we can change that object and make it back to its original form. So that's the idea of symmetry. And this is very important. This is very important idea in mathematics and also in physics and maybe in biology. It's everywhere in science.
Lakeem, can you tell us why this idea of symmetry is important, other than the aesthetics of it, and what does it lead to in terms of mathematical development or real life applications?
In this story of algebra, we were interested in the solutions, a lot of solutions of different equations, and somehow started with the idea of Galois. So where he actually started that, okay, you have a equation, let's say a cubic equation, it will have 3 roots from the fundamental theorem of algebra. Now, how many ways you can permute them, or how many ways you can make the symmetries out of that? So this was the very good idea. Okay, and then later, Sophocles came and he asked similar questions for differential equations, and differential equations have a lot of applications in a lot of areas to model a lot of different ways. So he then developed a symmetric method. Actually, there is a particular actually technical name for that. Symmetry analysis. Yeah. So he started symmetry analysis.
And in the story of algebra, you talked about, I think, one of the earlier people who came across this idea that the algebraic equations are also related to geometric solutions, right?
Yeah.
So did you think that helped the process of
finding very much
general equations?
Yeah, very much. I mean, look at these symmetries. What are they? They're just geometric transformations. They're nothing more than that. They are geometric transformations. All we need to do is to quantify and to calculate all possible geometric transformations we can have. So that was the idea. That was very much the idea behind, and I think it started, let's say, from Umar Khayyam. Actually, he saw this connection, very deep, interesting connection, that okay, you have different equations and you can solve them algebraically, but you can also solve them geometrically. He started looking at these solutions geometrically, and this geometric view was very, very important. And I think there was another mathematician in Germany. His name was Klein, actually, Felix Klein. His work was so influential. I think at some point I should give a talk on the story of geometry, where he actually he started a actually complete program of geometry and how to classify different geometry by using groups. this was his big program, and I think he started this program in Langan University. I once actually attended a workshop there, and Amin Adar was also there, and that program is very well known, and that program is known as a Langan program. There's another program, Langland program, but a Langan program was also much more fascinating in that sense. So Felix Klein was a colleague of David Hilbert. David Hilbert and Felix Klein actually developed this very famous mathematics department institute in Göttingen, where all these people like Einstein and all these people used to go there and talk about relativity and all these things. So, and Hilbert was also behind that, and Klein was also following all these ideas. So that was a big idea in that sense. Yeah, you're right. I think.
Why do we have all these Germans doing a lot of work in mathematics?
Oh, I don't know. They say that Germans love like Greeks very much, and they have this love of knowledge, and yeah, they have a very long tradition of doing all these things.
Nakib also regularly speaks at and attends the lectures at the Black Hole in Islamabad.
Yeah.
So you guys those who are interested particularly in mathematics but also generally science, you should also watch that online. They're really amazing.
Yeah. Good.
Great. Thank you very much.
Okay, you're welcome.
Team, thank you for doing the session. Really appreciate it.
Thanks for having me.